Hello everybody and welcome to the video. Today we're going to go over how to solve exponential equations. So these are equations where the variable is in the exponent. So to begin, I'd like you to think about what the value of x would be for these equations. So for the first one, we have 3 to the power of x equals 9. So what is x equal to? The second one, we have 3 to the power of x equals 27. And the third one, we have 3 to the power of x equals 20. Okay. So I want to encourage you to kind of pause the video and think about what the values would be for these three equations. Okay, so for the first one, there's actually kind of a simple value here for x here, and that value is 2, because 3 squared is going to be equal to 9. So in this case, x is going to be equal to 2. And much in the same way, for the second one, 3 to a certain power does give you 27, and that's 3 to the third power, right? So for the first two, x is just going to be whole numbers. X equals 2 for number 1, and x equals 3 for number 2. For number 3, it's a little more unclear. So you have 3 to the x equals 20. There's no integer that when you raise 3 to that power, you get 20, all right? Well, this is 20, and 20 is between 9 and 27. So there's a sense that x should be between 2 and 3. But is it 2.5? Is it 2.7? What is the value of x? So throughout this unit, we're going to be talking about how to solve questions like this, how to solve equations where the variable is right here in the exponent. So let's begin with some examples. Let's take a look at something like this. So we have 6 to the power of negative 2x minus 3 equals 6 to the power of x plus 2. So here's the key insight for the problems that you guys are going to be working on today. The key insight is if you have a to some power and that's equal to the same base a to another power, that means that the two powers are equal to each other, okay? And this only works if the base is the same. So if a is equal to a here, if these two are the same, number, then you can set the exponents equal to each other. Then b is equal to c. So in this case, because the base are both 6, so 6 and 6 right here, we can actually set the exponents equal to each other. So that's going to look like negative 2x minus 3 plus, so you make negative 2x minus 3 equals x plus 2. So then we just use algebra, add 2x to both sides, we get that. Then we're going to subtract 2 from both sides, and we get that. And then we divide both sides by 3 to get our answer. So in this case, x is going to be equal to negative 5/3 through algebra, okay? So we circle that, and that's going to be our solution. So remember, everybody, if the bases are the same, all you do is set the exponents equal to each other, and then you solve for x. Okay, everybody, let's work on our next example here. So for example 2, we have 25 raised to the power of negative 3x minus 3 equals 5 to the power of negative x. So in this case, the bases are not equal. Here we have that one of the bases is 25 and the other base is 5. But it is also true that 25 is equal to 5 squared. So we can actually use that to our advantage. So what we're going to be doing is we're going to be getting the bases to be the same. And we do that by changing 25 to 5 squared, okay? So that the bases are going to be the same. Now, the reason why I wrote it like this is because one of the exponent rules that you learned is if you have a to the b to the c, so if you have kind of two powers right here, that means that you can multiply those powers together, okay? We talked about this in our exponents unit, so just keep that in mind. So here in this case, this is really 5 to the power of 2 to the power of negative 3x minus 3, but you can just, multiply those two exponents together to get your solution, okay? So now that the bases are the same right here, what we can do, just like for example 1, is we can set the equations equal to each other. So 2 times negative 3x minus 3 is equal to negative x. So what we do is we distribute the 2 to both sides, right? We add 6x to both sides, and we get that equation. then we divide everything by 5, and then we get our equation is negative 6 over 5, okay? So for this one, just if you need to change the base, you should do that. And remember that when you have a power to a power, you can just multiply those two powers to get your equation, okay? All right, everyone, so let's take a look at our last example here. So now we have something like this, okay? This is kind of a more complicated looking equation, but we'll be able to figure out what it is. This says x raised to the 3x plus 1 times, 8 raised to the 3x plus 1 times 8 raised to the x plus 3 is equal to 64, okay? So what are we going to do here? Now we have these two terms that are multiplied together, so what are we going to do? Well, remember from our exponent rules that if you have a to the b times a to the c, if you have two expressions that are multiplied like this with the same base, that means that you can just add the bases together, okay? So you got to remember that rule to figure out problems like this. So moving on here, knowing that the bases are the same and that you're multiplying these two terms, what you're going to do is just add the exponents, okay? So this is really going to be 8 raised to the power of 3x plus 1 plus x plus 3, okay? That's how to sort of simplify it when you have two terms that are multiplied together with the same base, okay? And we also know that we can combine like terms here. So we're just basically adding these polynomials. So 3x plus x is 4x. 1 plus 3 gives you 4, okay? And then additionally, on the right-hand side, we have 64, but that's also equal to 8 squared, okay? And then because the bases are the same here, because they're both 8s, what we can do is set the exponents equal to each other. So we have 4x plus 4 is equal to 2. We subtract 4 from both sides. We get that 4x is equal to negative 2. Divide both sides by 4. And then we get that our solution is that x is equal to negative 2 over 4. And then we can reduce that by writing negative 1/2. Okay? So that's how to solve for equations when the variable is in the exponent. There'll be some cases later on where you won't be able to change this conveniently to 8 squared so the bases are the same. You need to use logarithms for that, but we're going to go over that in another lesson. So that's how you solve these type of equations.